Alright, it's 8 o'clock. I'm still waiting for about 20 more people to get on. Alright, it's 8 o'clock, so I'm going to start now. Okay, so hi, my name is Ethan. I'm in 9th grade and I'm going to high school. I'm going to be your teacher and I'm going to be teaching you everything you need to know about 5th grade math. If you're in 5th grade right now, raise your hand. Alright, that's great. If you're in 4th grade, you can raise your hand too. Alright, that's cool. Alright, and if you're in 3rd grade, you can raise your hand. Alright, that's great. Okay, so I'm going to share my screen now, and I'm going to share with you guys my presentation. So, Unit 1, whole numbers. So the first thing I'm going to teach you is place value. Each digit has a value that is based from its place value in the number. For example, the value of the digit 8 in the number 49,680 is 80 since it's in the tens digit, which is one digit left of the ones digit. As you can see here, this is the ones digit, and the 10 digit is one space left of the ones digit. Place value is based on multiples of 10. It's easy to find the place value of any digit in a number, since all you need to do is to count left from the ones digit. So like every place value has a certain amount of spaces you need to count left of the ones digit. So these are all of the place values up to 100,000. So this is the George Washington dollar bill. This is the ones place value. So I'm going to write an example number here. It's going to be my demonstration of all of the place values. So the ones place value is always going to be the number on the right. So it's 6 in this example because it's always the smallest number. It always has the smallest value in the number. And it's always the number that we use to determine all the place values of the other numbers. So our next place value is 10, which is one space left of the ones digit. So our tens digit is going to be 5 here because, and that's we have a bit more value than the ones digit. And our next digit is going to be the hundreds digit, which is 2 spaces left of the ones digit. So can someone tell me what the hundreds digit is in this number? You can unmute.
400.
Yeah, that's correct. The answer is 4 because it's 2 spaces left. 1, 2. It's this number. It's 2 spaces left of the ones digit. So the thousands digit is 3 digits left of the ones digit, which is right here. And the next digit, the 10,000s digit. Did you know that there was a $10,000 bill back then? Which is pretty interesting. I never knew that either. And it's 4 spaces left, which is 2. And finally, you have the hundreds thousands, which is the biggest value of digits, and it's the 1 here. And the more left of the ones digit a number is, the higher value it is. So you can use that in order to help you solve problems. So expanded form. So this basically expanded form is another way to write a number. So place values of every digit can be found by breaking up the number and writing it in expanded form. You can write it in standard form by multiplying and adding the numbers. So like you can just multiply all these numbers and add them together in order to make them into this normal number here. So what I do, this is this is the number we want to write in expanded form. So, oh, by the way, you should probably, I'm going to turn off annotating, you guys. So what I'm going to do, oh, oops, wait. What I'm going to do is I'm going to have this number right here. And so what I'm going to do is first I'm going to take this number, which is 4. So I'm going to find the place value of that. I'm going to count the number of spaces left from the 3, which is the ones digit. So 1, 2, 3, 4, 5. This is 5 spaces left of the ones digit. So it's going to be 100,000's place value. So what I do is I'm going to write this as the digit, which is 4, times 100,000, which is place value. And so next I move on to 5, which is the next digit from 4. I count all the spaces, 1, 2, 3, 4. And as a result, I found that 5 is the 10,000th digit since it's 4 spaces away from the ones digit. So I wrote that here. And next we go to 1. So it's 1 times 1,000 since 1 is 3 spaces away from the ones digit. And we keep doing this with all the numbers starting from left to right until we get to the ones digit. And for the ones digit, we write 3 times 1, since we already know that it's the ones digit and we don't need to count anymore. So I prepared some practice questions for you guys to do. So you guys can do these problems. I'll give you a couple of minutes to do these. And if you guys have any questions, you can always unmute and ask me, or you can type it in chat. So you guys should be done by now. I'm going to do these problems for you, and I'm going to say all the answers. So you guys can hold up your answers on the camera, or you guys can tell them to me in chat. All right, that's cool. So for your first times, for your first time, you guys did pretty well. I'm going to do these problems for you guys. So the first one is, first I take the 4 and I find the place value. So 1, 2, 3, 4, that's 4 places. So that is 10,000's place value. And then I'm going to write it as 4 times 10,000. And I noticed a lot of you guys wrote it as 40,000. Well, that is correct. It's not how you write expanded form. In expanded form, you write the digit times the place value. You don't write the number. So you're supposed to write it like this. And so next I just do 5 and I find the place value, which is 1,000 since it's 3 spaces. And so I just add 5 times 1,000. And I do this until I reach the ones digit. So 2 plus 2 times 100 plus 9 times 10 plus 7 times 1. All right, so this should be the correct answer. You guys can check your work. All right, I'm going to clean up. I'm going to do the next problem. So this one, I select the 6 first. I find the value of that. 1, 2, 3, 4, 5. So that's 5 spaces. So it's 100,000's place value. So I'll write it as 6 times 100,000. And it's not 600,000 because we have to write it this way. Oh, okay. And next we do the 2, which is the 10,000's place. And we do this at 20,000. Oh, I just did the same thing I was telling you guys not to do. 2 times 10,000. And then next we do 4 times 1,000 plus 9 times 100 plus 2 times 10 plus 6 times 1. You guys can check your work. And also when you're writing expanded form, make sure to write the largest digit, the largest place value first. And because like if you have to write the largest place value first because it's easier to read since you're like starting with the one on the left instead of the one on the right. All right, so now we have slide. So word form. We write a number in word form by converting it to expanded form and then writing that number into words. Then we convert it back to standard form by writing the words into expanded form, and we put it back into standard form if you want to change one from word form into standard form. So what I did with this one is first I found the expanded form of this one. We already found this one. So it's 4 times 100,000 plus 5 times 10,000 plus 1 times 1,000 plus 1 times 100 plus 9 times 10 plus 3 times 1. All right, then we just write that into words. It's actually pretty simple. So, but this time we have to find everything before the comma first. So that would be 451,000. So we had to combine that. I'm going to disable annotations again. And All right, guys, please don't write on this thing because I'm trying to teach people how to do math and you're ruining it for other people. So try not to do that. So I prepared some practice problems for you guys. I'll just give you a few moments to do these. You can block for your end. Yes, well, all right, so you guys should be halfway there or done by now. So I'm just going to give you guys the answer for the first word. So this is an expanded form. It's actually word form, which is basically the number, but in words instead of numbers. So first, for this one, I'm going to find the expanded form, which is 23,000. Stop. So the answer is 2 times 10,000 plus 3 times 1,000 plus 5 times 100 plus 8 times 10 plus 3 times 1. And this is the expanded form, but it's not actually the word form. So I'm just going to write this in words. So I find all the digits before the comma, which is 23,000, and I'm going to write that here. 23,000 Oh my God. Wait, let me just clear this up so I can write it again. 23,500 583. All right, so you guys can check your work and I'll give you a moment. All right, and for the next one, yeah, thanks for the advice. I'm going to type here. The answer is 463,136. So you guys can check your work here. All right. So if you guys have any questions, does anyone have any questions? You can unmute yourself for chat. Can you guys make sure you're muted, because if you're not muted, you're going to make random noises in the class. Your audio is glitching out a lot, so I can't hear what you're saying. Anyways, I'll just move on to the next slide. Alright. So greater and smaller numbers. To find the greater number of a pair of numbers, you should look at the two numbers and choose the one with more digits. If they have the same amount of digits, look at the first two digits and see which one is bigger. Then you can move on to the second number of digits, and you can move on to the third digits, and so on and so forth. Finding the smaller whole number is basically the same thing, but you can choose the smaller number instead of the bigger number. All right, so I'm just having some issues right now. I can't click it. I can't click it. You guys can take a break for now. I'm just trying to figure out what's happening. Just hold on a second. I'm having some technology issues. I'm trying to figure out how to, because like I can't click on anything, which is really weird. Guys, I'm just gonna leave for now, and I'm gonna rejoin. I'm back. So basically, I just had some technology issues, so I had to leave and rejoin. So now everything should be working, so we can continue with class. All right, so I'm just gonna move to the previous slide. Greater and smaller whole numbers. To find the greater number of recursive numbers, you should look at the two numbers and choose the one with more digits. If they have the same amount of digits, look at the first two digits and see which one is bigger. If they are the same, move to the second digits and so on and so forth. All right, finding a smaller number is the same, but you choose the smaller number instead of the greater number. So I have some examples that I'm going to do. So I am going to find the greater number for the first two. So I can see 204,591 versus 98,762. So what I'm going to do is I'm going to count the number of digits here. So this is 1, 2, 3, 4, 5, 6 digits, and this is 1, 2, 3, 4, 5 digits. And so what you need to do is you need to compare the amount of digits. So this one has 6 digits while this one has 5 digits. This one is bigger because 6 digits is greater than 5 digits. So that means this number is the greater one. So now we're going to move on to the next one. So 967,193 and 864,226. So I found that these two have the same number of digits, which is 6. And then what I'm going to do, and these numbers have the same amount of digits. So what I'm going to do is I'm going to compare the first two digits and see if they are different. So they are different, and 9 is greater than 8, which means that this number is greater than this number. And the third one is 352,203 versus 351,592. So they have the same amount of digits, as you can see, 6 digits. And the first digits are also the same, 3 equals 3. So now we move on to the next digits, 5 and 5. They're also the same. So now what I'm going to do is I'm going to look at the next digits, 2 and 1. And 2 is greater than 1. So this number is greater than this number. Oh, and these are just more examples. So as you can see, these should be pretty easy for you guys. This one has more digits than this one. So this one's the smaller number. This one's first digit is greater. So this one is smaller. And these ones, this one's third digit is greater than this one's that digit. So this one's smaller. Should be pretty easy for you guys. So I have some practice problems for you guys. I'll just let you do these. If you have any questions, you can message me. Otherwise, just do them. Guys, try not to have conversations in chat because then it distracts other people who actually want to learn the math. And I understand that you guys already know how to do this stuff, but try not to distract the other students in the class. So you guys should be done by now. So first one is this one. So this one has 6 digits, while this one has 5 digits. So this one is greater than that one. For the second one, we find a smaller number instead, and some of you actually sent the wrong answer since you guys didn't read the problem correctly. It's actually the smaller number, not the greater one. So first digits are the same. Since they have the same amount of digits, we look at the first digits, they're the same. So next we move on to the second digits, and 8 is greater than 0, so this one is smaller than that one. For the third one, we find the greater number, and they all have the same amount of digits. And so the first digit, again, they're the same. And the second digit, this one is greater than this one. So that means this one's the greater number. All right. So we have, so adding whole numbers now. Now we're adding whole numbers. We add them by starting from the lowest digits of the two numbers. We add them together, and then we move on to the tens digits. And then we keep moving on to the next digit on the left until we reach the last digit. And if sum of 2 digits is more than 9, then we use the units digit, the ones digit of the number that is the sum of those 2 digits, and we add 1 to the sum of the digits on the left. So here's an example problem. 7 plus 1 is 8. Then we move on to the tens digits. 8 plus 2 is 10. So we just use the ones digit of 10, which is 0. And we add 1 to the next set of digits. 1 plus 3 plus 6 is also 10. So we just put 0 here. We add 1 here. 1 plus 4 plus 5 is 0, is 10 again. We write 0 here. We add this. And 1 plus 2 plus 8 is 11. So we put 1 as the ones digit. And since there's nothing in the next slot, we just put another one there. So the answer is 110,008. So I have a practice problem for you guys. I'll just give you a moment to do it. So you guys should be done by now. I'm going to show you guys the answer. So what I'm going to do is I'm going to add these two numbers, 341,361 plus 236,124. So 1 plus 4 is 5, 6 plus 2 is 8, 3 plus 1 is 4, comma, 1 plus 6 is 7, 4 plus 3 is 7, and 3 plus 2 is 5. It should be pretty simple. So you guys can check your work, and in a few seconds, I'll move to the next one. All right. So I have another practice problem for you guys. This one's a bit harder for the first one, but it's still pretty easy. I'll just let you guys do it. All right. So it seems like you guys are finished with this one as well. I'm just going to give you guys the answer. So 100, 102,403 plus 519,197. So I'm going to add these two. 3 plus 7 is 10. I'm going to add 1 here. And 1 plus 0 plus 9 is 10. So I just add 1 here. And 1 plus 4 plus 1 is 6. And 2 plus 9 is 1, is 11. I'm going to add 1 here. 1 plus 0 plus 1 is 2, and 1 plus 5 is 6. So this is the correct answer. Subtraction of whole numbers. So subtraction should also be pretty easy, except instead of adding, you subtract each digit from the ones place. If the digit on the bottom is greater than the one on the top, just add 10 to the digit on the top and use that, but subtract 1 from the digit to its left. So here's an example problem. 1 minus 0 is 1. We move to the next set of digits, which is 4 and 3. 4 minus 3 is also 1. And now we move here to the hundredths digit. But 8 minus 9 is, we can't do 8 minus 9. So instead, we just add 10 to 8 to make it 18. 18 minus 9 equals 9. But we subtract 1 from the 4 on the top. So we just put 9 here. 3 minus 4 is 9, and we just subtract 1 here. And 2 minus 2 is 0, so we don't write anything here. So the answer is 9,911. All right, so I have another practice problem for you guys. So now you guys should have all gotten it, so I'm going to give you guys the answer. So what I'm going to do is I'm going to write it like this. So 5 minus 7 is, we can't do 5 minus 7, so I add 10 to 5, which makes it 15. 15 minus 7 is 8, so we put 8 here, and we subtract 1. But we can't do that, so we have to add 10 to 0, which makes it 10. 10 minus 1 is 9, so we write 9 here, and we have to subtract 1 again here, and 0 minus 5 is, we can't do that, so 10 minus 5 is 5. We put 5 here, and we subtract 1 here. 1 minus 3, that's just 8, and we minus 1 here, and 8 minus 1 is 7. So the answer is 78,598. All right, I'm going to have the next problem. So this is the next problem. I'll just let you guys do it. Can you guys stop disrupting the chat because you're interrupting the people who want to learn, and that's kind of rude to the other people who want to learn the math. Did you guys do the problem? If if you have the answer, just send it to me in the chat. All right, I'll just wait until you guys finish. All right, so most of you, it seems like most of you are done. So I'm going to give you guys the answer. So I'll just do it right now. 21,553 minus 10,094. 3 minus 4, we can't do that. So we add 10 to 3, which makes it 13. Which in the answer of 13 minus 4 is 9. We subtract 1 from 5, which makes it 4. 4 minus 9. We just add 10 to 4, which makes it 14. And we get 5. Then we minus 1 here, and 4 minus 0 is 4. And since we didn't add 10 to the digit, we don't have to subtract 1 here. So 1 minus 0 is 1, and 2 minus 1 is 1. So the answer is 11,459. Okay, number patterns. These should be pretty easy. They are actually really easy to figure out. All you have to do is to find the rule from the other numbers and use that to find the missing numbers. So in this problem, yeah, you're correct actually. It's pretty easy to find the rule. All you have to do is subtract one from the other, and 200 minus 100 equals 100. And this is the rule. Every number you add 100. So you can see that 100 plus 100 is 200. 200 plus 100 is 300, and 300 plus 100 is 400. So we know that's the rule. So 400 plus 100 is 500. 600 plus 100 is 700. And 700 plus 100 is 800. So yeah, that's how you find patterns. It's not hard. So I have some practice patterns for you guys. I'll just let you do these, and if you have any questions, just chat it to me. Also, if you want to give me the answers, can you private chat them to me so the other people can do it themselves? Yes, Colin, did you want to ask a question?
Accidentally.
Because you raised your hand, did you want to ask a question?
I accidentally raised it. I don't know how.
Oh, it was an accident? Okay, that's fine. Okay, so it looks like most of you are done now, so I'm just going to give you the answers to the first and second problems. So for the first one, the rule here is plus 200, plus 2,000, I mean. We can see that in all of these numbers. So 10,000 plus 2,000 is 12,000, and 12,000 plus 2,000 is 14,000. So that was the answer to the first question. Now for the second question, we can subtract 2,500 from 3,000, just minus, and that equals 500. So the rule is adding 500 for every number. So you can see it in here. And 3,000 plus 500 is 3,500. 4,000 plus 500 is 4,500. And 4,500 plus 500 is 5,000. So that should be the answer for the second problem. And for the third problem, I'll just demonstrate it for you guys. This one actually looks kind of hard, but it's really not. All you have to do is subtract 1,955 from 255 equals 100. So the rule is to add 100. Once you figure out the rule, it should be pretty easy to complete the pattern. So this is 1,255, and the next one is 2,355. So that was the answer to the third question. So now we have rounding numbers. To round a number, we need to take the place value that it needs to be rounded to, and we look at the two closest multiples of that place value. Then you pick the one that's closer by looking if it's above or below the middle of those two numbers. So for the first one, we have to round this one to the nearest 100. So what I do is I look at this number over here. This is the hundreds place value here. And so I just turn everything after that into zeros. So my first number is 12,500. And the second closest multiple is just this, but you add 1 to the hundreds value, 12,600. And the middle of this is 12,550. And if you can compare if the original number was higher or lower than 12,550. So you can see it's lower because 46 is lower than 50. So therefore, we just round to the first one because that's the one it's closer to. 12,500 is the answer. Now for the second one is 26,183. So what we do here, we do the same thing as the first one. We get the hundreds value here, and then we have to find the two closest ones. So 26,100, since you change everything after the hundreds value to 0, then the 26,200, since we just add 1 to that. The middle is 26,150, and we know that 83 is greater than 50, so we actually rounded to the second number, which is 26,200. All right, I'm just going to give you guys some more practice problems. Make sure to pay attention to what the question's asking, because it asks you to round to a different place value every time. So I'll just leave you guys to do it. I removed Bob because he was disturbing the class. So if you can tell him to not do that again, then I'll let him rejoin. Yeah, I kicked him out. All right, so you guys should be done with all of these problems by now. So for the first one, what I do is look at this number, 23,592. So I look at the thousands digit, which is 3, and I find the two closest multiples of 1,000, which is 23,000 and 24,000. And next, what I do is I'm going to find the middle, which is 23,500. And as you can see, 592 is greater than 500. So that means that this rounds up to the second one, which is 24,000. And for the next one is 10,550. So you round that to the nearest hundred, 10,550. So the two closest ones are 10,500 and 10,600. Since you just add one to the hundreds value for the second one. And the middle is 10,550. And actually, both the number and the middle of the two closest values are the same. So what I do here is I round up. So I round up to the second one because when you have the number that's the same as the middle of these two numbers, then you always have to round up. That's the rule in math. All right. So estimating sums and differences. To estimate a sum or a difference, all you have to do is to round the numbers and then do the addition or subtraction. It's easier to round to the place value that is just right of the first digit. So it's easy to add them and it's still a good estimate. So estimate the sums and differences. So what I do is I round both of these numbers. So 24,000 and 11,000. And what I do is I add them and I just estimate it and I get 35,000. This sign is actually the sign for an estimation. So that means it's not equal, but it's still pretty close. This is actually what you use when you show that you're estimating something. And the next problem I'm going to do is 49,719 minus 27,027. So what I do is I'm going to round this to the nearest thousand because it's just to the right of the first digit, 50,000. You should always estimate to the place value that is just right of the first place value. So for example, you would just, if you had to round hundreds like 359, you would always round to the nearest tenth, which is 360. And if you have like 345,000, you round to the nearest 10,000 since it's just to the right of the first digit. So 350,000. Anyways, I'm going to continue with the problem. So 50,000 minus 27,000. And that is equal to 23,000. That's the estimation sum. So these are the estimations of the different sums and differences. So I have some practice problems for you guys. Estimate this sum and estimate this difference. It won't take too long. I'm just going to let you guys have a few minutes to do it. So it looks like most of you did the first problem already, so I'm going to do the first problem for you guys. So what I do is I round this to the nearest thousand first because that's the digit that's just right of the 10,000th digit. And so I get 2,000, 26,000. And then the next one, I round it to the nearest thousand again, which is 11,000. I add these together and I get 37,000, which should be a good estimate. And for the second problem, a lot of you guys did that too. So I'm going to do this one. This one's estimating the difference, so you subtract it, not add it. So I'm going to estimate this one, 94,000. Since we're rounding it to the nearest thousand. And the second one is 73,002. So you just subtract that and you get 21,000. All right, so if you guys have any questions, you can just private chat to me.
No questions for me.
Do you have a question?
No, I do not have a question.
Oh, okay.
When is class supposed to end?
It's supposed to end at 9 o'clock. Oh, it is 9 o'clock. Okay, so we are out of time. It was a pleasure teaching you guys. I'm going to see you guys next week. Bye.
Okay,
Bye.
thank you.
No problem.